Enjoying everything you're seeing today. I hope you're having a good time. I'm really excited for this next keynote. It's probably been about a year in the making. Last October, Autodesk came out and they brought their entire gallery that they have in San Francisco out to Paris last year. What am I saying? Last summer. And I got to meet Autodesk for the first time, and we started talking about how hardware companies were using 3D printing to actually build products, and it wasn't just a maker thing. And we talked about this yesterday, and now we're going to talk about the future of making things. So before I invite up our keynote from Diego, we're going to roll a quick video, and then we will welcome on stage. So let's roll the video. Ladies and gentlemen, Diego Tamburini. Let's give him a round of applause. Yeah, awesome, man. There you go. You got a picture there for the slides.
Well, good morning, everyone. In the next few minutes, I'd like to share our vision of what we think that the future of making things will look like, as well as some thoughts around the forces that are shaping the future of how we design and manufacture things. So first, let me step back for a few seconds and talk about what are the outcomes that manufacturers look for today. I mean, of course, the main thing that keeps people awake at night in manufacturing is productivity. So everybody wants to increase productivity. And they do so by tweaking the two sides of the productivity equation. So on the denominator side is the inputs. So they try to reduce costs. They try to reduce labor costs. They try to use cheaper materials. On the numerator side of the productivity equation, they try to increase output, basically. So they do that by adding automation or implementing some initiatives like lean manufacturing and so forth. The other thing that manufacturers want to do is to squeeze as much juice out of their production processes. So depending, particularly for some very sophisticated production processes, they also want to innovate with the production processes themselves, again, to gain an edge over their competitors. And of course, innovative. So all manufacturers want to disrupt the market. They want to introduce innovative products, And that's been forever. What's changing is the speed as to what customers expect that you'll be innovating, and also the disruption. People are expecting disruptive changes. So the times where you could release a product and have it for 20 years and just make minor tweaks, those are gone. The expectations are much stringent on disruption and innovation. So those are the outcomes that manufacturers have traditionally pursued. So let's look now at what are the trends, the forces, technological forces, business forces that are shaping the future of making things. But first, let me cover this part that says that arguably technology is behind all disruption. And in this case, it's not deception. So there are 4 main technology areas that are disrupting the manufacturing industry. And from the top left is cloud, obviously. I mean, infinite computing and infinite storage is now available for everyone, and that's very powerful for manufacturing. And also because it's making it easier to software vendors like us to deliver services and products on a subscription basis. So you rent the software. You don't pay for it anymore or pay for the perpetual license. Then is that data that is over there in the cloud is now accessible from multiple devices, multiple form factors, from anywhere, from any time, from mobile devices, from your desktop. And there is also the social aspect of it, is that your customers and the new workforce was born and raised in the connected, in the social networking era. So your customers are heavily connected, and you know that to reach them, you need to play the social networking game. And lastly is the 3D printing. I mean, 3D printing, granted, is still not ready for mainstream mass production, but arguably is the fire behind the maker movement. So those 4 forces, technology areas, have caused disruptions in these 4 areas. The font is not coming across very well, but I'll read them. So on the top left is demand. Then we have the products themselves, and then we have the means of production, the means of intellectual production, and the means of physical production. So I'll cover each one of those in the next slides. So on demand, who the customers are, where they are, and what they want is changing dramatically and very fast. So let me give you a few figures just to give you an idea of the magnitude of the changes in global demand. One is 9.6 billion. So that's the expected population of the planet by 2050. Currently, it's about 7, so you get a picture of the growth. It's also expected by 2015, there will be 1.8 billion people entering the consumer class in the planet. And these people are from developing countries, not necessarily the developed countries of today. And it is expected that the consumption by developing countries by 2050 will go from $12 trillion US dollars today to $30 trillion. So that gives you an idea of how diverse, how fragmented, how geographically distributed the demand is. And that, of course, places unique challenges in manufacturers, because now they have to satisfy a demand that is completely different from what they have today. Customers also want more and more personalization. They want the products tailored, not just customized, but tailored to them, to their bodies, to their chemistry, to their preferences. And also, customers are increasingly expecting that products will get better with time. So we love this example from Tesla. I don't know if you remember about a year ago that Teslas were catching fire. So they traced back the issue to the suspension. It was actually a suspension problem. They thought it was a battery problem, but it was a suspension. It was too low, and in certain driving conditions, it was just scraping the floor and catching fire. Once they detected the problem, they issued an over-the-wire software update. And 24 hours later, all the Teslas in the planet were fixed. So how's that for a recall? So products, the bottom line here is that people are expecting hardware products to become better with software updates. And then there is also, people are just growing more and more conscientious about the environment, about the social impact of how things are made, about the transportation cost to the environment. And they're choosing products and companies increasingly based on the social and environmental impact rather than on price alone. And this is not hippie talk anymore. It's not rainbows and unicorns. This is actually something that is starting to provide some companies with a competitive differentiation. So it increasingly needs to be strategic for companies. Okay, so that was demand. Moving into production. So the two sides of this slide are meant to be production. The top one is the intellectual production, meaning how we design, how we ideate things. So one thing is obvious, collaboration. Since we've been developing products, we've collaborated, so that's not new. But what's new is that the nature of collaboration. One is incredibly geographically dispersed, but also companies are starting to realize that the best ideas could be outside their walls. And they're starting to become more permeable to outside ideas and engaging customers and engaging communities, people who don't necessarily work in the company. And then there is the attitudes toward intellectual property. So sharing and reusing intellectual property is not considered cheating anymore. So in fact, it's considered smart. Why are you going to reinvent the wheel and find a new solution to a problem if there is already one out there? So of course, for the lawyers in the room, that's problematic. But setting aside that for a moment, it just makes perfect sense. Why not, right? The software industry has been doing it for some time with open source software, and now we're increasingly learning about open source hardware. And I put our 3D printer there, the Ember, which you can see outside, because all the blueprints of the hardware, the software, and even the materials are available open source for anyone to look at, to improve, and to use. The access to funding, of course, yesterday we had a session, Indiegogo was here, and we talked about Kickstarter, and obviously, the old model of having to go to a bank or to a VC to get funding is being challenged by crowdsourcing. And the interesting thing about this is not only do you get the money, but you also get an implied market research because people are voting with their credit cards. And this is, in my opinion, the most interesting part of the means of intellectual production and how they are changing. Imagine for a moment if computing power were infinite and virtually free. How would you change design? So in Autodesk, we're trying to answer that question ourselves. So this is an example from a project that we're running at Autodesk Research. Basically, we provide the computer the parameters and the design goals and the design objectives. And the computer, using cloud computing, generates a huge amount of alternatives, and then analyzes each one of them, and then proposes a few viable alternatives for you to choose. So think about this. This is kind of the way we do development today, but instead of a gazillion choices, we have to pick a handful, and then we want to eliminate them very quickly because it's expensive to analyze and to consider many options. That's gone. So the result is that you don't have to throw away potentially good or potentially the best option too early in the development process, and that you get much better, much innovative products. And also on the computing power, so we saw generating and analyzing huge design spaces, but there is also the ability to generate the geometry. So this is a heat exchanger that was, its geometry was generated by an algorithm, a program. So basically you tell it, I need fluid to go here, to go out, I need this heat exchange, calculate a geometry for me. So this is very interesting because it's changing the way we define geometry. I mean, today, designing was largely an exercise of defining the shape of the object. So now we're using the computer more and more to do that. Okay, on the physical side of the means of production, obviously, 3D printing has changed the way people do product development, much more rapid prototyping, and it's also establishing itself as the production model for very complicated shapes, relatively low product runs, and highly customized or personalized objects. I personally believe that that's going to be the sweet spot for 3D printing. And just like the microwave didn't replace the stove in our kitchen, the 3D printing is not going to replace the NC machines, the millings, the routers, and all that. It's just going to be one more tool in the toolkit. And then there is automation. What's interesting about automation is that more and more, the approach towards automation is to create robots and machines that work with humans instead of replacing humans. And I'm personally of the side of the band that is optimistic about the introduction of automation in factories. I think they will actually be better for working environments and productivity, and that the job loss will be temporary, in my opinion. There are others who think otherwise, but that's another topic. In manufacturing, too, the ability to have a global supply chain and to have a production environment is becoming more accessible to everyone. So we are seeing, just like the big companies hire Foxconn or companies like Foxconn to do mass productions, we are seeing small, more distributed Foxconns that basically do manufacturing for hire. Some people call that manufacturing as a service, distributed manufacturing. And that's a trend that is going to be interesting because it's allowing hardware startups and entrepreneurs to have bona fide manufacturing. And materials is obviously going to continue to be a critical factor. We heard yesterday that it's a critical factor in 3D printing. It's a critical factor because there are more pressures to have more sustainable, lightweight materials, to reduce the use of conflict materials. And so composites, bio, nano, and interestingly too, another thing that will change the way we will do design is that we will design the material itself. So the structure of the material at the molecular level. And there will be design tools, just like today we have CAD tools to define geometry. We'll have material design, material engineering tools to design materials. So to conclude this part, I have a couple of examples. So this is a heat exchanger. The reason it's interesting, it's several reasons. So one, it was 3D printed from one block of materials. There are no parts, there's only one part. 2, it was designed by an algorithm. And, oops. It was designed by an algorithm. And 3, that it has incredibly much more efficiency and heat transfer properties. The other example is this car. This is the Strati from a company in the US called Local Motors. One thing is interesting, obviously, is that the whole body was 3D printed. So that's interesting on its own. But also because the design was actually crowdsourced. So there was a challenge issued by Local Motors, and many people around the world proposed designs, and this is kind of a hybrid of several proposals. So that's a nice story. So finally, on the products themselves. So let me share a few figures again in a round, because I mean this is a connectivity Internet of Things conference. The analysts vary widely in the numbers. I mean they expect anywhere from 25 to 50 billion things connected to the internet or to each other by 2020. Choose any end, choose 25 billion, it's still a big number. The other is 8.9 trillion US dollars is the expected revenue from those Internet of Things devices in 2020. So there are lots of devices to be designed, and there is a lot of money to be made. Even if you consider these figures conservatively, it's still a big market. So I think I'm preaching to the choir with this audience. The change here, we've been designing connected things for a long time. Smartphones, PCs, video gaming devices. What's changing and what's disruptive is the nature of the things that we are connecting to each other. Cars, cows. I like to call that the Internet of Cows. The kitchen devices, I mean, you've seen that in the connected home. Trash cans. I mean, I like the idea of the one of trash cans. This is a company called Big Belly, and they have trash cans everywhere. In universities, airports, the city of Boston has these trash cans. What's interesting is it doesn't get more mundane than a trash can, but by connecting them to each other, they're actually able to incredibly optimize their trash collection services, and now they're thinking about, okay, since these things are everywhere and they're connected to the internet, what other services can we provide? So something that has been around for a very long time that is not interesting is a box. They made it interesting and more useful. And of course, what has enabled all these things to come and connect to the internet is that on the Internet of Things, nobody knows that you're a fridge. And even shy and socially awkward fridges can participate in the Internet of Things. That was a joke, by the way. It didn't land very well. Okay. Still in the products, what's really interesting for product developers is that now, particularly the ones that used to be traditionally mechanical, is that they're not designing just products, but they're designing software platforms for third-party developers to develop applications on top of them. So that changes the game dramatically, because people who were used to design the electronics and the mechanics, now they have to think, okay, what API are we going to provide? What software development toolkit are we going to provide? What types of scenarios will we be involved in? So it's really changing. And you can see software companies just fighting their way to be the operating system of the Internet of Things, like, I mean, most notably Microsoft and Google, and be also the connection glue between them. So you can see companies even like Facebook getting into the software development area of the Internet of Things. The other aspect is, now that we have all these things connected to the internet, of course you can provide added services. It was mentioned earlier, things like monitoring or preemptive services, because you can predict when things are going to fail. And this is changing the things so dramatically. Like, for example, GE and Pratt & Whitney, they are actually providing, they're not selling the engines to the airliners anymore, they're selling kilowatts per hour. So they take care of everything. Their engine stays property of the company, but they actually sell by the outcome, not by the product. And then, since these things are all interconnected to each other and to the internet, they are producing huge amounts of data that are constantly being pumped to the internet of the big data tank. So the question is, what can we do with it? How can we improve processes? How can we improve our products? So properly analyzed, this data can provide invaluable insight. So that's our interpretation of the things that are disrupting the manufacturing industry. So what? Well, we believe that, of course, whenever there is disruption, there is opportunity. And the unique things about this is that this disruption is not only very profound, but it's very fast. So there is a lot of opportunity for, in our opinion, small startups to big enterprises to really capitalize on these trends. And it also means that innovation is not the monopoly of big enterprises anymore. Anybody could come with an idea that is going to change the world, from a student in a maker lab in a school to somebody at tech shop or in a hacker space. The innovation now is accessible to more and more people, which is, in my opinion, good. So let me change, to conclude, start wrapping up. Let me change gears a little bit and reflect on, from the point of view of software for design and manufacturing, what have been the various phases in the history of CAD and CAE. So the beginning, we used, when we introduced CAD, we used computers to document our designs. So we basically used them as glorified pencils and rulers. It was very good, was very disruptive, but we just documented our designs for manufacturing, for downstream processes. As computers got better and more powerful and software got better, we successively merged into an era of optimization, where not only did we use computers to document our models, but we used them to actually perform the design, the analysis, and the simulation. We are kind of on the tail end of this era, in our opinion. What we're about to enter is what we call the era of connection. What does this mean? Well, in the era of connection, the design will transcend just the 3D definition of the shape, but it will take into account connectivity from the beginning. So connectivity to other devices, connectivity to people, connectivity to infrastructure. So instead of optimizing things, considering them as silos, as independent things, we'll optimize entire systems. So we are starting to develop the tools to do those things. We still don't have them. Nobody has them. And we're starting to think, what will those tools look like? So to close, we really believe that we are at the brink of a revolution of the likes of the Industrial Revolution. This goes beyond just technical toys, but it's actually something that is disrupting the fabric of the industry. Is something that has social and economical impact, and in our view, is very bright and very exciting. So with that, I hope you enjoy the discussion, and merci. Thank you.